Hi students, my name is Thirupathi. I am working as assistant professor in Triple department in Marri Laxman Reddy Institute of Technology and Management. Today I am going to discuss the topic of auto transformer. This auto transformer topic is available in BW subject in the first year of CSC, CSC allied branches and uh, ECE first year IEE subject, the Introduction to Electrical Engineering and Basic Electrical Engineering. In these two subjects, the auto transformers topic is there. So, auto transformer topic is not only for BW and IEE, it is also there in triple branch also. So, today, these auto transformer is very important. Why? Because to start the motor or to control the voltage, majorly we will use the auto transformer, and to control the speed also we are using the auto transformer. So here the point is to start, to control, to increase or to decrease the voltage, we are using the auto transformer. It is a best method. So today we will discuss about the auto transformer, the construction details, the working, and by using of this auto transformer we can also save the copper winding. So saving of the copper, there we have a small derivation with the comparing of the two winding transformer and advantages, applications, and working of the auto transformer. In this class we are going to discuss. Okay, so now see here the diagram we are saying. This diagram is a practical diagram of auto transformer, which is not useful visible in the outside. Why? Because it's covered with the outer surface of a yoke. Okay, so if you observe here, this area, total area is, the core is covered with the copper winding, and this is we can show in a single line diagram. Here you can observe. Okay, so this is the practical diagram. This practical diagram is redrawn into a single line diagram to evaluate and to study the concept of the auto transformer. So here you can see here. Okay, so here we have only one winding. This one winding will be divided into two. So one will be act as a primary winding, another one will be act as a secondary winding. In the same manner, the number of turns will be changed from the primary to the secondary, and the current entering into the primary winding and the current leaving from the secondary winding is also changed. So that all the things we will be discussed now. Okay, so here we are seeing that one is the practical one, another one is the single line diagram for the analysis. And here you can see the practical diagram is redrawn for a single line diagram. So if you observe here, the A, B and the C, and here we have a circular core that is called as toroidal core, and these toroidal core we wounded with a winding, and this wounded winding in the middle we have a sliding contact. So when this sliding contact is connected to the terminal A to E and the D contact, so that if your number of turns changes, then the output voltage will be changed. The number of turns is changes, then the current also changes. So when the slider moves, if you want to increase the voltage, the number of turns should be increased by moving of the slides, so that the induced EMF of the voltage will be increased. In the same manner, if the number of turns is reduces, then the voltage also decreases. So by this way, we can vary the voltage to increase to decrease. So wherever we are using a voltage control method to control the speed, there we can use this auto transformer. And wherever the motor takes high amount of the current in starting, then we can use the auto transformer. By increasing slowly the number of turns, then the voltage increases, then the current increases, so that slowly the starting current will be increases. By that we can protect the motors. Okay, so here we have a diagram. So we have a core, and core is wounded with the winding, and that winding contains a slider. So by varying of that slider, the primary windings and the secondary turns will be changes. And here now we are going to study about the theory concepts. So the first one is the transformer with one winding only. So the part of these being common to both primary and the secondary. So here we have one core, on that one core, we are placing the one winding, and that one winding will be divided so that one will be act as a primary, another will be act as a secondary. If you observe here, from A to B, we have a total winding. From observing the point from A point and the B point, this total winding for primary winding. And from observing the point C to B, then it is a secondary winding. Okay. So from here, we can observe the C, and here we have a B. This BC is a primary winding here, and here A and the B is the secondary winding. And we know that the load connected terminals are the secondary, the supply connected terminals are the primary. Okay, so here we are connecting supply to the AB, so it is act as a primary, and here we are connecting the load for BC, so this BC will be act as the secondary winding. And here we are connecting input to the BC, so it is act as a primary, and here we are connecting load at the terminal of AB, so it is act as a secondary. Okay, so here the construction, if we go for the construction details, we have only one core and the one winding, and that one winding will be divided into two parts, so that the one terminals will be act as a primary and another two terminals will be act as a secondary. Okay, so its theory and operation are similar to two winding transformer. So the operation and the concept of these transformer is similar to the two winding transformer. Okay, and we know the definition of the transformer. Okay, transformer is a static device which transfers the electrical energy from one circuit to the another circuit without change of any frequency. Okay, according to Faraday's law of electromagnetic mutual inductance law. Okay, so here, because of one winding, it uses less copper, hence it is cheaper. If you use the two winding system, we required two winding systems, one winding separately taken for primary and second winding separately taken for the secondary circuit. Okay, but here we are only taking one winding, and that one winding itself act as a primary and the secondary winding. Okay, and here we have a equation, transformer ratio equation. Okay, V2 by V1 equal to N2 by N1 equal to I1 by I2 is equal to K. And here we will see the working principle. So in the working principle, first we will discuss about the single winding design. Single winding design. An auto transformer uses a single continuous winding placed on a magnetic core which serves as both the primary and winding. Previously here we seen, so see here I am drawing. Take this. This is a magnetic core. So in this magnetic core, we are placing the winding. Okay, single winding, and these single winding will be act as a primary. Now we are giving for a supply of V1, so it has act as a primary. Now I am taking a tapping point and connected to a load and again to the another terminal, so it is a secondary coil. Okay, so this way we can use the single winding into primary winding in the secondary winding. And next one, AC voltage input. AC voltage input is nothing but we are giving to the primary side AC voltage input. Okay, so now this total selected area contains the voltage of V1, and here the point, let us think, this is the A. Okay, this is A, and this is the B, and this is the C. This AB now act as an input and the BC act as an output. So here I am taking the voltage as V2. So this V1 is the input voltage and this V2 is the output voltage. And here we can change the tap changing. So let us D. Okay. So now BC voltage is less than the BD voltage. So by adjusting the tap, we can change the number of turns. By changing of the number of turns, the output voltage will be changed, but the input voltage is same. Okay. Now magnetic flux generation. The alternate input current produces a fluctuating magnetic flux in the core, forming the basis of voltage transformation. We know when a current is passing through a coil around that coil, the magnetic field will be produced. So now we place the winding on a magnetic core. So when this winding get the supply, the current will be flow through the winding, and around that winding, the magnetic flux will be produced. And the next one is electromagnetic induction. So here, if you observe, here we have only one winding and the one core, but in two winding system, we have only one core and the two windings. So there we have a mutual inductance, but here we have a self inductance. Okay, so that is about the electromagnetic induction. So according to Faraday's law, the changing flux induces a EMF across the entire winding, enabling using transformation with the same coil. So when the flux is passing through this total winding, in this winding, the EMF will be induced according to the Faraday's law, and that induced EMF can be vary by changing of the taps. And the controlled voltage output. So by changing the number of winding and the tapping positions, we can control the output voltage. The next one, efficient power transformer. So we can transfer the primary power to the secondary power very efficiently. Okay, so here the auto transformer transfers the power through both inductive couples and direct electrical conduction, improving efficiency. Okay, so we can direct transfer the power from primary to secondary winding. And flexible voltage adjustment. So we can adjust the voltage very easily by we have a knobs. So by changing of the knobs, the secondary voltage will be changed very flexibly without any uh, trouble. Okay, and here the most important thing is the difference between the auto transformer and the two winding transformer is the most important one point is saving of the copper. In two winding transformer, it required more amount of the copper to do the operation. For that same operation, this auto transformer will take the less amount of the copper. So now we will see how much the amount of copper is going to be saved. Okay, so here we have a small derivation, we will see it. So here some points we have the volume and hence weight of copper is proportional to the length and area of the cross section of the conductors. And we know if the voltage increases, the insulation material will be increases. If the current increases, then the conductor size will be increases. Means the area of cross section of the conductor will be increases by increasing of the current. Okay, so the voltage increases, the insulation increases, the current increases, then the area of cross section of the conductor will be increases. Now length of conductor is proportional to the number of turns and cross section depends on current. Okay, here the length depending upon the number of turns. If it is more length, we can turn into more number of turns. Okay, but the current rating can be decided by using of a conductor size. Okay, hence weight is proportional to the product of the current and number of turns. So now the weight. So to weigh the winding thickness as well as the length of the winding will give the total weight of the winding. Okay, so if its cross-sectional area is more, then it will be thick, so that the weight will be more. Okay, and if the number of turns are more, then the weight will be more. If number of turns are less, then weight will be less. So if you multiply it with the number of turns and the current, we will get the total weight. Okay, so see here, so weight of copper in section AC is, so this is AC, here we have A and this is the C. So here the total number of tons are N1. So we know the total number of tons are N1. If you subtract the N2 tons, so if you see here, this total number of tons, this is N1. Okay, so from this N1, here we have N2. Here we have N2. So to know the AC section in this total number of turns, if you subtract this BC, then you will get the the number of turns of AC. So N1 minus N2 into I1. So the I1, the current which is flowing through the AC. Okay, and see here you will get the clearance. The weight of copper in the section BC So in the BC, the number of turns are N2. The number of turns are N2. Okay. Now in this winding, the flowing current is, that is nothing but I2 minus I1. I2 minus I1. Now in the section AC, the weight of the copper is N1 minus N2 into I1. The copper weight of BC section is N2 into I2 minus I1. Okay. So now we know the weight of AC section and the BC section. And the total weight of copper in auto transformer is nothing but by adding of the section AC and the BC, we will get the total weight. So here if you see the total weight of copper in auto transformer, N1 minus N2 into I1 plus N2 into I2 minus I1. Okay. So now we got the total copper weight of auto transformer. Now we have to go for two winding system, two winding transformer. Okay. So if a two winding transformer were to perform the same duty, then weight of copper on its primary is N1 I1. So here we are not dividing the primary winding, so that we are taking total number of turns N1 and the total amount of current is carried by the N1 winding is I1. So N1 into I2. So let's see. So this is a two winding transformer. So here we have a core. So this is the primary side. So primary side, I have the windings of N1 and the current is I1, and this one is the secondary one. So secondary is connected to the load. Here we have number of turns is N2 and the current is I2. Okay, but here the single winding is divided for primary and secondary, but here the primary is separate from the secondary is separate from the primary winding, so that the weight of copper in its primary is N1 into I1 and secondary is N2 into I2. For total weight of two winding transformer is N1 I1 plus N2 I2. So here we can see total weight of copper is directly proportional to N1 I1 plus N2 I2. So now to find the formula for the copper saving, so here we have total weight of copper in auto transformer by total weight of the two winding transformer, and we know N1 minus N2 into I1 plus N2 into I2 minus I1 is a total auto transformer copper weight by N1 I1 plus N2 I2 is the total copper weight of the two winding transformer. If you take it, then we will get a equation of 1 minus K. Okay, here the K is a transformation ratio. So weight of copper in auto transformer, WA is equal to 1 minus K into weight of copper in ordinary transformer, W naught. Just we are sending this one to right hand side, so that it is multiplied with the 1 minus K. So here W naught is nothing but the weight of the ordinary transformer, and WA is nothing but the auto transformer. Okay, so W naught minus WA is equal to W naught minus, so WA we already know, this is 1 minus K, and this is the ordinary transformer. So in the place of WA, we can substitute 1 minus K into W naught. So if you simplify it, we will get K into the weight of ordinary transformer. Ordinary transformer is nothing but two winding transformer. Okay. So saving percent is equal to the transformation ratio into 100%. Okay. Hence saving will be increased as K approaches unity. So if the K approaches to unity, the saving of the copper also increases. Okay. So this is the copper saving of auto transformer equation. Nothing but saving percentage equal to K into 100%. Okay. And the saving quantity is K into W naught. Next, the advantages of the auto transformer. So the first one is an auto transformer requires less copper than the two winding transformer. Just now I saw the diagrams. So in two winding transformer we have two windings, primary and the secondary. So it required more copper. But in the auto transformer we taken one copper winding, and that one copper winding is divided into primary and the secondary, so that the copper winding will be saved. And second point is an auto transformer operates at higher efficiency than the winding of similar rating. So when the copper winding is reduces, the copper losses will be reduced. So we know in transformer we have only two losses. One is iron losses, another one is the copper losses. The iron losses will be maintained constant. So here the copper losses will be variable. The copper losses will be increased with respect to the load. So if you save the copper, then the copper losses will be reduces. If the copper losses reduces, then the efficiency of the transformer also increases. Okay, so that is the meaning. And the third one is an auto transformer has better voltage regulation than a two winding transformer. Obviously, so when the losses reduces, efficiency increases, then the voltage regulation also improves. And the next one is an auto transformer has a smaller size than the two winding transformer at the same rating. So if you take the two transformers, one is auto transformer, another one is the two winding transformer for the same rating. If you compare the size and the weight, the size and the weight is less in the auto transformer than the two winding transformer. So that is also one other advantage we have. Okay, the size will be reduced, the cost will be reduced, and the size also less for the same rating. Okay, and next one, fifth one, an auto transformer requires small exciting current than a two winding transformer of the same rating. So auto transformer required small amount of excitation current compared to the two winding transformer. Okay, in two winding transformer we have to increase the excitation current. Why? Because in from the primary to secondary we have a magnetic path for by using of the core. So that flux should be carried from primary to secondary. So it required more excitation current. But here we are placing primary and secondary winding on the same core. So it requires less amount of the excitation current. So these are the advantages we have in the auto transformer. Okay. The next one, application of auto transformer, it is very important for us. So first one is for safely starting the machines like induction motors, synchronous motors as a starter. Okay, so we know if you start a motor, initially it draws 10 to 12 times of rated current, so that the winding will get damaged. To avoid that, we have to increase the starting current slowly. So to do that, we are connecting the auto transformer. So by varying of the number of turns, the voltage will be increased according to the turns. In the same manner, slowly the current also increases, so that we can protect the motors from the high starting currents. And the second one is to give a small boost to a distribution cable to compensate for a voltage drops. So it is also used like a boosters. We can observe outside some pole mounted transformers. Okay, they are auto transformers. Okay, so when a line is there, distribution line is there, if the on that line the load is increases, then it will there is a voltage drop. So to compensate that voltage drop, we are using this auto transformer. Okay, in transmission lines we will use capacitor banks, synchronous condensers, okay, synchronous advisors. So many things we will use to compensate. Okay, but in distribution lines we can use this auto transformer also like a booster. That is one of the application of auto transformer. And the next one is as a furnace transformer to supply power to the furnace for required supply voltage, we are using the auto transformer. For furnace, we want to increase the current. Okay, so to increase that, we have to increase the voltage so that the current will be increases, so that the furnace heat will be increases. Okay, and next application is for interconnecting the systems which are operating roughly at same voltages. So the same voltage is nothing but isolation transformer. So every device there will have some losses. Okay, for example, for the same output auto transfer, I given 230 volts, but the output, if I given the output is less than the 230, so by changing the number of turns to increase the number of turns, then the voltage will be increased to 230 volts. So by that way, I will get the exact voltage. So that is also called as isolated transformer. Means this auto transformer is also act as like a isolator. Okay. So if you take the primary winding same number of turns in the two winding system and the same number of turns in the secondary winding system, if you give the primary voltage as a 230 volts, but you will not get 230 volts at the secondary winding. Why? Because due to the losses. Okay. But in two winding system, we can't increase for 230. Okay. So whatever the dropped voltage we get in the secondary, we have to consider it. But in the auto transformer, if you give the 230 volts, if you want the 230 volts, by increasing of the number of turns, by varying it, we can get the 230 volts. So that is the advantage we have in the auto transformer. So that is also one of the application we have. So this is about the auto transformer. So thank you for this class.